All right, now in this exercise, we're trying to write a program to convert 34.0 degrees Celsius and convert it to Fahrenheit. And the equation for this is when we're converting to Fahrenheit, it's going to be equal to 9/5 times the number of degrees Celsius plus 32. So here's our main method down here, and inside we're going to declare everything as a double because Celsius is written as 34.0, so that's a double, and Fahrenheit's going to be a decimal at the end of the day, so we're going to declare that as double, and so on. So here we go. We have Celsius is 34.0. That's what we're defining that input to be. And then the equation that we need is Fahrenheit, that's the answer that we want, is equal to 9 divided by 5 times the number of degrees in Celsius plus 32, which matches essentially what we're doing up here. So the answer that we get is held in the variable Fahrenheit, which is double, which can hold a decimal. And then we're going to print it out and say degrees Celsius, Celsius is equal to however many in Fahrenheit, Fahrenheit. So this is just formatting the output. This is the number of degrees Celsius, this is the calculated answer in Fahrenheit, and the text in between is just to make it look nice. So once we have this here, let's go and run it. So we've already saved it. Let's go ahead and hit run. 34.0 degrees Celsius, or 34.0 Celsius, is equal to 93.2 Fahrenheit. So that's what you get when you take 9/5 times 34 degrees plus 32. So this is the answer. And in this particular case, if you do it in a calculator, you're going to get 93.2. So I just want to caution again, if you need extreme precision, if you have lots of decimals, 34.379232 Celsius, and you're trying to get an exact conversion to an exact decimal, there are other math libraries out there that are going to carry that precision better. But in this particular calculation, it's all correct. So that's the answer. Let me show you one thing. It's a common mistake. So it's 9/5 times Celsius plus 32. Notice we wrote it as 9.0 divided by 5.0. Let me show you what happens. Notice the answer is 93.2. If I take this 0.0 away and I take this 0.0 away and I hit save and then I run it, notice the answer changes completely. 34 degrees Celsius, 34.0 degrees Celsius is equal to 66.0 degrees Fahrenheit. That's completely wrong, and that's a very common mistake most people would kind of scratch their head with. What's happening here is Celsius is a double precision floating point number. Fahrenheit is a double precision floating point number. When we do this calculation in terms of this division, when you don't put any decimal points anywhere, then Java is going to assume that it's an integer type of division. 9 divided by 5, 5 can only go one time into 9. So since there's nothing here telling Java that this division is really floating point, it's just going to truncate it. It's going to give this answer as 1. So 1 times the 34 that we have is going to give you 34 plus 32 is going to give you 66. So it all boils down to, because we didn't tell Java what to do here, it's going to do an integer division, and it gives you the wrong answer. So the way to override that is to make sure and tell Java that these are actually floating point numbers, and so any remainder that comes out of this division is going to be carried through in terms of a decimal point. So if you ever have constants, the lesson here, if you have constants in any calculations with floating point numbers, make sure and put a decimal there. Even if it's really a whole number, just stick a 0.0 there. When we run it again, we'll get the correct answer. And that's basically how you do this problem here. You declare everything as double precision floating point, do the calculation, output the result.